All right, and welcome to the Daily Space Weather. Lots of stuff to talk about today. A massive, strange coronal mass ejection on the far side of the sun, Cosmology, and Sunspot 2844. The activity we're seeing is going on in the southern hemisphere of the closest star. Here's Sunspot 2844 rising right at the end of the video, right there at a very, very high latitude there. Much higher latitude than the other sunspots we've been seeing. And we just saw a C-class flare come out of this sunspot group right over here, which nearly evaporated and then suddenly was reinvigorated. It actually formed and got more complex. Here's a full disk view to show you also Sunspot 2842. Moving just about into center longitude. So let's take a look at the viewpoint from Stereo A. We've got some quite strange data to show you. Stereo A located here at Lagrangian point 5. And check out this coronal mass ejection. Now, if this would have been on the Earth-facing side of the sun, we would have forecasted this. However, keep in mind that we only forecast coronal mass ejections when they are in approximately this area, because we're only concerned with ones that are in the Earth vicinity. So we include the poles, but we do not include coronal mass ejections in this area, only in this area. Anyway, check out the way the plasma propagates here. This is quite interesting indeed. There's about 9 hours of missing data here. We're going from 7:15 at 20:53 straight to 7:16 at 5:23. So 9 hours of missing data there. And this is very interesting, the way that this plasma is propagating here. I've never quite seen such a thing, and it would be nice to be able to see the rest of the data. But in any case, I'll let it play through for you here a couple more times, at least once more. I'll let it play through twice more to show you this very interesting far side coronal mass ejection. I think it's actually multiple events is what we're seeing here. And while we did see some minor activity from that new sunspot, once again, the majority of the flaring came out of a reinvigorated sunspot. We'll show you that on the next frame. So there's the view from Stereo A again. That's located at Lagrangian point 5. Some very odd plasma propagation there. So here's the SDO view from 304 angstroms wavelength. And you can see this area right over here. This is where the series of flares have been happening. Right there. You can see that sunspot brightening up as it increases in complexity. There was also a coronal mass ejection that propagated from this area. So lots of activity here despite generally low numbers. It's a prime example of why you have to look at what's going on with the sun in order to know. And basically it requires vigilance to, I don't know, have a clue. And you can see some of the coronal mass ejections happening here in this area, as well as the great brightening of this sunspot. I think it's 2843. Don't quote me on that. I try not to memorize sunspot numbers too much, as I'm able to forecast the future, and I don't want to get caught up in memorizing roughly arbitrary numbers. If you're wondering about astrography, where things are located in the sky, well, here's a diagram of the solar system. We'll advance it 1 week. There's where things will be in a week. It looks like a full moon shall be on the 24th. The radio flux has come up slightly here to 74. And we can expect to see this continue to increase with increased sunspot activity. So there's the 1-year chart to put that in context. The black line is the radio flux, the red line is the sunspot number. No forecast for geomagnetic unrest or storms from NOAA. There's the 3-day KP forecast from NOAA. No arguments there at the moment. Let's take a look at global seismicity. There's been a massive earthquake drought. Over the past 90 days, we've only seen one 7 magnitude earthquake. So if you're in an earthquake-prone zone, please have an earthquake plan, as earthquake droughts end in large earthquakes. So quite low levels of seismic activity here over the past 24 hours. There was a deep quake at Vanuatu at 4.5 magnitude. Over 188 kilometers estimated depth for that earthquake. And we're just scrolling up the list here. There's not really a lot to talk about. No big quakes. Really, it's an earthquake lull, although there has been a small swarm in the Antelope Valley once again. Shout out to Smash Staff's mom. And let us know if you felt that quake if you're living near the California-Nevada border. And there's one of those quakes. It looks like it's at extremely shallow depth on the eastern edge of the Sierra Nevadas. And there you go, right south of Topaz Lake there in the Antelope Valley. We've seen a bit of an uptick there recently. Anyway, that quake happening at 1.7 kilometers above sea level, 1,700 meters above sea level. So here's the largest of the past 24. This quake, a 5.5 at Japan. Quite low levels of seismicity here over the past 90 days, and indeed the past couple of days. Let's check volcanoes. Suwanosejima remains on the list. It's exploding. It's producing a 10,000-foot plume of ash. I think that's an uptick at Suwanosejima. Sinabung, which is probably the deadliest volcano of the past few years. Some volcanian explosions detected from its crater. A modest ash plume, less than 2,000 feet of altitude there. 35 volcano tectonic earthquakes. Tokono, flight level 8,000, flight level 080. It's an 8,000-foot plume of ash. Now Rupahu on the North Island of New Zealand, now showing up on the list. Early 2021, the lake associated with Rupahu volcano cooled before starting to heat again in March. A maximum of 41 degrees C was reached on April 12, 2021. The lake then started to cool down to 20 degrees C. On July 2nd, the lake temperature has started to rise again last week and is currently 23 C. So that's something to keep an eye on there. Once again, Rupahu. So also some likely magmatic earthquakes happening there underneath that lake. The results from continuous measurements of volcanic gas temperature and water level indicate that a key monitoring parameter remain within normal ranges. The lake is currently overflowing into the Wangahu River. Great names there of things in New Zealand. Fuego exploding also in Guatemala. Flight level 150 as it produces a 15,000-foot plume of ash. Sangay exploding. Flight level 220, 22,000-foot ash plume. Revenador, also in the country of Ecuador. Volcanic ash not observed in satellite. Don't assume it's not erupting. Sabancaya exploding. Flight level 230, Nevados de Chilean. Sporadic emissions are a reminder not to pole vault the caldera. Please don't pole vault the caldera, folks. It could be unhealthful. Now, while Steve Stimpak died in a tragic table tennis accident, not while pole vaulting caldera, he still didn't want the kids pole vaulting caldera. It's not safe. This public service message brought to you by youtube.com/smashomash and smAsho.com. Visit our websites. And we've seen an uptick happening here. Once again, a flare occurring as we make our video. A C-class flare just reaching peak flux, it looks like here, at around 8:40 Universal Time. So a little uptick there. Again, those flares are coming from the sunspot in the southwestern limb of the sun. We'll take a closer look at that later in the video. No spikes in the proton flux. None of those coronal mass ejections are headed Earth's way. Here's the ghost magnetometer over the past 3 days, and it's showing low lows and low highs, at least over the past about 36 hours. And let's look at more magnetic data. Here's the top view ecliptic plane field plot showing us the polarity of the heliospheric current sheet. Keep in mind this is not to scale, and the imagery also shows you stereo A and stereo B located at Lagrangian points 5 and 4 respectively. One of the most important data sets that we have, part of the National Sunspot Observatory. Earth is in a North Pole current sheet, and we expect to remain there for the foreseeable future. Here's the line of sight ecliptic plane field plot. A three-dimensional view from Earth's perspective of the same data. And that blue line gives you an indication into the sun's B field activity. The next frame will show you the sun's B field and potential field surface source lines. Here's that, the line of sight coronal hole plot. The blue lines are the B field. The green regions are the North Pole-oriented coronal holes, and the red regions are the South Pole-oriented coronal holes, and we can see some evidence of solar polar field reversal happening here. You can see this North Pole coronal hole reaching down here toward the south, and vice versa. That is part of the process that occurs during a solar polar field reversal cycle, which is well behind schedule in cycle 25. And perhaps we'll do another video on that, as the first one we did only got a couple hundred views. Oh no. Seems like a lot of people have no idea what's going on with the sun. Part of the reason why we have a channel, because of people who are very, very confused about the physics, or just ignoramuses. Remember, folks, ignorance is the root of all knowledge. There's nothing wrong without knowing something. And while there are no stupid questions, there are lots and lots of stupid people. So here's Sunspot 2843, and that's the source of those flares. Here's Sunspot 2844. It'll get a name today. Certainly, it's quite large. It's about the size of planet Earth. And the detected coronal holes isn't even showing up with anything. By the way, if you want to read about these different features here of the Integrated Space Weather Analysis Center, just click on Info, and it will tell you all about it. Feel free to pause the video if you need to read that. Let's show it again in case you need to pause the video. Cheers. KP index only at 1. Global geomagnetism is at calm condition. A KP of 1. Next, we'll look at the real-time solar wind. Give it a moment to load. It's an active applet. And we've recently seen the BTBZ converge on the 0 line, so that's pretty uneventful. The phi angle has been shifty over the past 12 hours. And we're seeing some errors likely here in the solar wind data. So when you see these yellow bars down here, that is an error suspect. And it has to do with sudden changes that are not likely based on the physics. You can see all these wild swings here in the both the solar wind density and the velocity. Are they real signals? I'm not entirely sure. And I won't get too much into the likelihood of errors on this. Current solar wind conditions are about 5.25 protons per cubic centimeter. Solar wind speed elevated here. This is some more coronal hole wind likely. And the error bars have evaporated just in time for us to make our video. Solar wind velocity currently at 460 kilometers per second. Let's take a look at the geospace of space out to about a dozen Earth diameters. It's the magnetohydrodynamic pressure shown in nanopascals. And it's based on the space weather modeling framework, our geospace magnetosphere movie, showing pretty homogeneous pressure here in the geospace over the past 4 hours. That's 4 hours of data. Pretty uneventful there. Let's take a look at ground magnetic perturbations, changes to the Earth's B field. And by the way, when you see these areas start to turn red, this does give you insight into likely places where we're seeing magnetic induction into power grids, which occurs more the closer you get to the pole, obviously. Maybe not obviously, but it does occur more the closer to the pole you are. Anyway, that's 4 hours of data. Changes to Earth's own B field. Next, I wanted to show the Aurora 30-minute forecast, just to show you how you can clearly see here that the South Pole is quite a ways from the South Geographic Pole. North Pole a little bit closer to the North Geographic Pole. And this is probably one of the best data sets here to give you insight into the current polar excursion. And when you see red on this, it just means you've got a 90% chance of seeing aurora if you're located on that part of the planet. And you can see them calming down here. Likelihood of auroras has dropped. Now, we put our videos in 3 different locations. If you want to check those out, it's twitch.tv/smAsho, bitshoot.com/smAsho, and youtube.com/smAsho. Twitch is a fantastic live streaming platform. And they've got a great mobile app as well. It'll alert you when we put up videos, when we go live. If you're viewing on YouTube, don't forget to press like and subscribe. And you likely are, as most of these daily space weather videos only appear on YouTube. Thanks to our new subscribers on that platform. Also, check our playlists if you haven't seen those. youtube.com/smashamash/playlists. We've got all kinds of playlists you may not have been aware of. So make sure you check those out. More to come. Yeah, there are even recipes, folks. And we're over 200 cosmology segments now. And there's the BitChute page. More exclusive content coming there. Thanks to our subscribers over on BitChute if you're viewing on YouTube. And everybody, leave us comments. Let us know where you like to view the videos the most. Any preferences that you may have about the content, anything like that. Let us know. We read all of our comments and we take them quite seriously, even when they're silly, because I've been known to stray from being totally serious to being totally silly promptly. We've also got a Discord channel, and if you want to find an invite to that, head to smashamash.com. If you click on this arrow, you'll see all of our social media. One of those is an invite to the Discord channel. We've also got merch links in the smAsho forum, which we've recently updated. Today's cosmology segment will be integrated into the daily space weather video. So let's talk about our mission. You can read about the mission at smashamash.com/forum/mission. And we're going to talk about number 5 today, which is to publish scientific papers in a multidisciplinary manner, including but not limited to sciences such as spectroscopy, chemistry, astrophysics, health and wellness, and longevity. And let me stop right there. We've updated the forum on our autophagy thread. If you're not familiar with what autophagy is, go read the thread. It's in the free-for-all forum at smashamash.com/forum. Today we're not going to pick a random number at all. We're going to talk about Cygnus X3, one of the most significant objects in the galaxy. It is indeed the most intrinsically luminous object visible from Earth. And it all has to do with the orientation of its stellar jets. So Cygnus X3 is a high-mass X-ray binary consisting of a massive Wolf-Rayet star, which is a very hot, very bright, very energetic blue star. And I would show you it in X-ray, but it's not showing up there. Here it is on the 2MASS. This is infrared light. And what's going on in this system is a massive object is orbiting that Wolf-Rayet star, creating a huge ionized disk of gas and dust in between the two. And one of the stellar jets from that object that orbits the Wolf-Rayet star is oriented directly at Earth. It's one of the only known cosmic ray point sources And let's take a look at it in optical here. Here it is on pan-stars. Let me just press refresh here. Let's bring it up on pan-stars here. Just give it a minute. Anyway, there it is in pan-stars optical bands D and Z. I don't know why it looks so dimly. But in any case, Cygnus X3 is super important. Again, it's one of the only known cosmic ray point sources. And it's in an ultra-quiescent state right now. So if you look at the historic graph here, here's the 16-year graph in the upper right. And it's way down here, about as quiet as it ever gets. You can see right here, here's the 0 line on the 30-day chart. And it's been in a quiescent state here for an extended period. As you can see from the chart, it's quite cyclic. And we would like radio astronomers to get this in radio frequency, all kinds of radio frequency, before it returns to its X-ray loud state, as it'll give us all kinds of insight into the plasma jets that are oriented at us. And again, this is a source of cosmic rays, folks. In other words, especially if you're in the northern hemisphere, this thing has been sending protons all the way through your brain for your entire life. And it was discovered in an underground facility back in the 1980s. And by the way, it only takes 4.8 hours for an orbit the size of Mars's orbit to occur, meaning that this massive object is traveling at relativistic speeds. The ancients believed Cygnus X3 to be the source of all life and the location to which your soul returns upon death. Göbekli Tepe is oriented toward Deneb, the tail of the swan, which is the star associated with Cygnus X3. X3 is referring specifically to the more massive object orbiting the huge Wolf-Rayet star. And that Wolf-Rayet star, by the way, puts out about 10 times the solar wind speed and density of the sun. And it's about the size of Mars's orbit. Let's take a look at the astronomy picture of the day, which is from the Congo. And you can see some Earth shine here on a crescent moon. And if you look up, 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 and we encourage you to look up on the channel, you'll see Venus and Mars. So there's a great view, the astronomy picture of the day. You can look at it yourself if you like at apod.nasa.gov, apod.nasa.gov, the astronomy picture of the day from the Congo. Next, we're going to cover cosmic rays. And we've seen an uptick here at Apatity over the past week, although it remains mostly flat on the last 30 days. Here's Barentsburg, which is a tiny uptick here over the past 30 days. So there's two monitors that are very far north that are a little bit, they're not just steadily lowering. Let's go farther south to Athens, Greece. So here's the cosmic ray monitor in Athens. Pretty flat here over the past 30 days there at the Athens, Greece neutron monitor. Let's take a look at the Mexico City Cosmic Ray Observatory, and a significant downtick here over the past 30 days there, and a similar downtick over the past 7 days. So it's interesting how we see a different cosmic ray environment at Mexico City versus at Apatity and Barentsburg. So let's go even farther south, right after we go even farther north. So first, Oulu, Finland. There's Oulu. And Oulu's seeing a slight downward trend over the past 30 days. And let's go as far south as we'll get to DOMB and DOMC Antarctica. So there's DOMB. Small uptick at DOMB. And a similar small uptick at DOMC. Anyway, that's our cosmic ray coverage. That's our cosmology segment. We integrated it into the daily space weather video. And make sure you check out our playlists, as our cosmology segments are a playlist as well. And there are over 200 videos in there. So check those out. There's all kinds of information about all kinds of strange, fascinating, and amazing things in space. Speaking of space, electrons can charge up our satellites. We don't see any of that happening right now. Everything is green. Here's a one-year chart of the electron flux surrounding planet Earth. And that is the electron flux at about 300 kilometers of altitude at the F layer. Here's a 3-day chart of it measured by the GOES 16 with radiography. More moderate levels of electron flux here. Here's the forecast. And I would tend to agree with NOAA's forecast here that we'll see a little bit of an uptick over the next few days, barring some unknown, unforeseen event. Here's a diagram of the Van Allen belts. Feel free to pause the video on this. Distances are shown in miles. And here's the total electron content forecast. We showed massive anomalies in this yesterday if you watched yesterday's daily space weather video. We even put it on the thumbnail, but watch the video if you want to see the full glory of the total electron content. There were massive anomalies south of Africa, the Atlantic Ocean, and South America. Today, everything's looking much more normal as electron flux levels have returned to more of a moderate range here. And this gives you an idea of where GPS errors will occur. It's showing you the total electron content for the entire air column. Next, we'll look at the F ionosphere layer. Again, feel free to pause the video here. The F ionosphere is located at about 300 kilometers of altitude. It's just one slice shown in vibrational frequency. And we've been showing some anomalies in this, and once again, we're seeing anomalies here in the northern hemisphere. Some unexpected charge up, or high vibration zones, I'll say, over places like Greenland and the North Atlantic. Anyway, if you don't look at it daily, you may not know what I mean by saying it's anomalous, but it's been looking anomalously here for a few days. And largely over the past about 2 weeks. Thanks for leaving a comment about it, Mary. And once again, this gives us insight into things like the Earth's magnetic field. The bridge between space and Earth is where lots of chemical reactions are happening. There's a lot of ions there, and when they meet up with more neutral particles, well, chemical reactions take place. Here's the latest image from 9 o'clock Universal Time. Things looking quite normal at that moment. Next, we're going to do a meteorology segment. If you're only watching the daily space weather videos, check out our meteorology segments. There's a playlist for it at youtube.com/smashamash/playlists. Meteorology segment complete. youtube.com/smashamash/videos to see stuff you may not even know we produce. Let's do bonus features. The first of which is the El Teide, Spain ground-based solar observatory in 6,562.8 angstroms, which is helium alpha. And you can see the brightening here of Sunspot 2843. That's the flare that happened while we recorded the video. Hey, thanks, Sun. We appreciate you doing all kinds of things when we make content to make our content better. It's almost like you're helping us forecast the future. So congratulations, El Sol, and congratulations to you, the viewer, for realizing our channel exists. Next, the GOES SUVI thematic map, which shows you all of the features, by the way. And the pink up here, which is off the scale, that is flaring. You can see where the flaring is located. The GOES 16 SUVI thematic map is great for people who know nothing about the sun because it tells you all the features. Look, prominence, filament, bright region, otherwise known as a sunspot in some cases, coronal hole, etc. The GOES 16 SUVI thematic map. Good times. Next, thanks to our patrons, the main source of funding for the content. You patrons are the associate producers of this content. So while most of the content is produced by Smash staff and I at massive personal risk and expense, our patrons are creating some expense for themselves and incentivizing us for continuing to create these videos and make them free and publicly visible. Thanks again, patrons. Patreon.com/smashamash for all kinds of perks nobody else gets. Sunspot 2844 is alpha class and unlikely to produce major flares. Sunspot 2843 is likely to produce additional flares. We could see an M-class flare come out of this as it has grown significantly in the past only few hours. Here's the magnetic field environment, and it is a classic beta-class sunspot. It's got multiple umbrae of opposite polarities, as you can see, and the red is the South Pole oriented, the blue is the North Pole oriented polarity. And again, Sunspot 2844 is just alpha class at this point. We only see one umbra, like Sunspot 2842. It only has one polarity, which makes it much less likely to produce major flares. 2843 is the one to keep an eye on. And when I say eye on, well, the pun is intentional. And here's some more composite imagery from the SDO, the Solar Dynamics Observatory. It's 3 different wavelengths of iron here. So 211, 193, and 171 are all different ionic states of iron. And we like this composite image. It's splentacular. Fantabulous. It's splentacular. And we'll just let this scroll here for a full disk view. Thanks again for tuning in, folks. Once again, congratulations on realizing that our channel exists. Please share the content on your social media. Tell us what your favorite social media is in the comments. And we'll be keeping you posted if anything else occurs. Thanks again for tuning in, and may that solar wind be at your back. The Daily Space Weather, a regular feature of the Smash News Network. Least busted, name it news.